So in this video we're going to look at this integral x minus 1 divided by square root of x with x plus 1 squared all in the denominator with regards to x from 0 to pi over 6. Now we've got a pi over 6 there. That's got to be some sort of clue that there's going to be some trigonometric substitutions or results coming from this integral somewhere. So where are we going to start? Now this integral has got several ways you could solve it. The way I'm going to show you here today has got 2 or 3 different steps, all resulting in trigonometry, hence this pi over 6. So square root of x, let's deal with that first. So we'll do a U-substitution for that. So we'll have u equals square root of x. So first business, du and our dx. So we've got du, square root of x, derivative of that, standard derivative, 1 over 2 root x dx. So let's get this isolated as dx. So then dx will equal 2. Now square root of x, we don't want to put that in when we've done the u substitution, but square root of x we know is u. So we've got 2u du. And then a couple of other things. We've got an x here. So then we'll have u squared equals x. So let's just make a note of those. And we've got an x plus 1 squared. So that's going to be, if I do x plus 1 squared, that's just going to give me u squared plus 1 squared. So that's ready now just to plug it into there. Now I've got my parameters. Now what happens with those? Well, when x is 0, I need to find out what u is. So square root of 0 is just 0. That's straightforward. And then I've got pi over 6. So when x is square root of pi over 6, that's my u for lower. And I've got square root pi over 6 equals u for my upper. So that's going to be my upper bound. Okay, now let's plug it all in. Let's see where we go. So boundaries are 0 and square root of pi over 6. Then I've got x minus 1, so that's u squared minus 1. And then I've got square root of x, which is just u. X plus 1 squared, as we did here, u squared plus 1 squared. So that's all squared. And then my dx is 2u du. So then I've got all of that times 2u du. So let's just leave the 2u there and then du. Okay, now they're all multiplied in the numerator, so that's all good. So now let's sort out some simplifications and see if we can tidy things up a little bit. So I've got my u's cancel, my 2 can come out the front. Then I've got a situation with u squared minus 1, which is like a difference of 2 squares, but this one not quite. I've got u squared plus 1 squared. So let's rewrite that. So now I've got 0, square root of pi over 6. Then u squared minus 1, that's going to have to stay, but this 2u will move, so I'll just leave it as u squared minus 1. 2 out the front, the u's cancel, so the numerator is taken care of. And then this is cancelled, so u squared plus 1 squared. And then, of course, my du. Okay, now, what am I going to do now? This looking like I could get some sort of tangent squared plus 1 or inverse tangent or something could happen here. But that would be good if I had a u squared plus 1 in the numerator. So why did I put 1 in and then subtract 2? So if I change that to plus 1 and then subtract 2, I've still got u squared minus 1 in my numerator. And then what I can do is split my integral into 2 parts. So let's do that. So now I've got 2, 0, square root of pi over 6, u squared plus 1, so that's going to be my first part of my integral, over square root of u squared plus 1, u squared plus 1 squared, sorry, not square root, and then that's going to be a du. And then I'm going to have another integral which, don't forget, this constant multiple and our bounds of integration. So it's going to be a minus this time, and 2 here. That 2 goes here because it's minus, but I've also got a 2 in the numerator of my integrand. So I'm going to put that in there first, and then we'll deal with that after. So square root of pi over 6, 2, and then I've got my denominator as I had here. So that's got to stay same on both sides. Okay. Now here, straightforward, I can just bring that 2 across. That'd be no problem. So if I change that from a 2 to a 1, change that to a 4, then I've got 2 integrals running separately. This u squared plus 1 will cancel out with this one, but I've still got my 2, and then I'll have an inverse tangent situation, so that's good. So I've got 2, 0, square root of pi over 6, so that cancels out with that. So I've got 1 over u squared plus 1 du. So standard integral, that's going to be inverse tangent. This one, bit more work to do. Now I've got u squared plus 1. Now I know I've got this here. So I've got my inverse tangent here. That's all good. Here, I've not, maybe I need a tangent here as well. With it u squared plus 1, it seems good idea to do a substitution for tangent. So I'm going to let u equal tangent, substitute u for tangent theta, sorry. So let u equal tan theta. So that'll be my substitution there. And then u squared will be tangent squared theta. So that's good. So that'll give me a nice identity to see. And also what I've got there, I need to do my du. So du equals secant squared theta d theta. So that's all ready just to plug in for that. So this one, no worries. Let's get the result of that written up. So that's going to be 2 inverse tangent. So if I put a bracket around it, 2 inverse tangent. And what have I got? I've got from 0, well, inverse tangent of 0 is 0. And square root of pi over 6, that's my upper bound. So the inverse tangent of square root pi over 6. So that integral there now is all done and evaluated from the bounds. So that's good. Now let's do something with this. So we've got our substitution here. Let's plug it in, see where it takes us. So I've got minus 4. Now bounds of integration, what have I got there? Let's deal with those. So I've got 0. So let's plug in when u is 0. So 0 equals tan theta. So then theta is the inverse tangent of 0, which is just 0. So in that case, I've just got a 0 there. So now with this one, remember my theta would be inverse tangent of u. So I need to be a bit more careful with this one. So that's my u, that's what I've got for in the u variable. But when I change to theta, I need to go to this one. So then I'll have my theta upper bound. So I call that theta 2. That's going to be the inverse tangent of square root of pi over 6. So that's going to take care of that. So that's going to be what I'm going to have to put here. So it seems a bit weird putting a function in the upper bound, but that's what we got. So inverse tangent of square root pi over 6. Okay, so that's all good. Now we've got here, we've got 1 and I've got du, well, secant squared d theta. So I've got secant squared and then d theta. And then in the bottom, u squared plus 1 squared. Well, u squared is tangent squared theta. And then plus 1 all squared. Okay, well, got secant squared here and tan squared theta plus 1 here. Well, there's a good trig identity which I can use, which is tan squared theta plus 1 is secant squared theta. So then I can sub that in for there and get secant to the 4 theta. But then if I cancel that out, I'm going to have 1 over secant squared theta. So let's put that in. So minus 4 inverse tangent square root pi over 6. All good. Looks kind of weird in there, but I'm quite liking it. So 1 over secant squared theta d theta. So that's what we've just gone through. Okay, right, that's part of my answer. So I'm going to write that up here. So that equals 2 inverse tangent square root of pi all over 6. Let's just do that one big square root of pi over 6. Let's try and make that a bit neater. And then what I'm going to do is I'm clear the board, and then we're going to deal with this. Okay, so let's do that. Okay, so now we got this bit here to deal with, 1 over secant squared theta. Now secant is the reciprocal of cosine. So here we've got the reciprocal of cosine squared theta. But as that's in the denominator, I can just put cosine squared theta in my numerator and just return with a 1 in the denominator. So now I can rewrite this integral, and we're into familiar territory apart from this upper bound on our integral with cosine squared theta, d theta. Now there's many identities for cosine squared theta, but I'm going to put this one here, which I'm going to use here. That's 1/2 of cosine 2 theta plus 1. So now what I can do is just substitute that into there for it. So let's go with that. So I've got -4. Now I've got a half here. So instead of putting my half in there, I'm going to bring it out and bring this to a -2. So that takes care of that. So I don't need the fraction now, I'm just left with that. So put my upper bound back in. And then I've got cosine 2 theta plus 1 d theta. Okay, don't forget to close the bracket. Well, we're ready now, we can integrate now straight off. So cosine 2 theta, well, the integral of cosine is sine, and with the 2 theta by the reverse chain rule, I need another half in there. So then the integral for that is going to give me sine of 2 theta over 2. But now I've got this -2 here to distribute in here. So then that will just become minus sine 2 theta. So that's that finished. This one here is just a 1. Integrate that with regards to theta, I just get theta. But I've got this 2 here, so I still need to distribute that even though I used it with this. So I've got -2 theta. And this is all integrated from 0 to inverse tangent of all of that lot. Okay. So that's looking good now. So now I've just got to evaluate this at these. So then what have I got? Let's plug in where I see a theta, I plug in that. That's all I've got to do here now. So minus sine, let's put this in a bracket, 2 times all of that. So 2 times inverse tangent square root pi over 6. That's a crazy input for a sine function, but that's what it is. And then here I've got -2 at that. So I've got basically 2 of those. So -2 inverse tangent square root, let's get that all in there, pi over 6. Let's get that notation right. No need for a plus c because we're doing a definite integral. So then I've got that and that and that. So let's bring that down here. So that's 2 arctangent square root pi over 6. And now look, good things are happening here already. So I've got 2 tangent of this square root minus 2 tangent of that square root. So they cancel. So all I'm left with now is that. So this has gone. So I can take that off. So let's rub that out. It's not needed anymore. So all I need now is that. So that equals the negative sine of 2 of this inverse tangent. And then I've got square root pi over 6. And that's my result. Now, plug that in our calculator, you'll get approximately -0.95. So that is also approximately minus 0.95. Now you go on with loads of decimal places, but I'll just put it to 2 here. That's fine. Now there must be some triangle you can make of that. I'm going to leave that for you guys to draw. But if you could just draw me a nice right angled triangle and work out what that is, that would be great. So we're going to have some sort of angle theta, hypotenuse of 1, and we're going to get 2 sides here. So a side x and a side y. Okay, so with that, that's the result of the integral. Let's see if you guys can work out what this triangle is. Leave it in the comments below, that'd be great. And thanks for watching.